Hi, so today I'm going to explain these four topics: work, power, kinetic energy, and work energy theorem. So, first, I'm going to explain what is work. We can represent work by the letter W, and work is a transfer of energy from one place to another or from one form to another. Imagine that I am applying a force on a bench in my classroom, and as part of that, or as a result of the force applied, the bench moves. So there is a displacement. So if we multiply that displacement with the amount of force that I applied on the bench, I can calculate how much did work done is work I did. So we can calculate work done by multiplying the force into displacement. Force and displacement are vector quantities. So the work done is a scalar quantity. So it is only having a magnitude and not having direction. The unit of work is joule. We can represent it as by J. Okay, then my next topic is power. We can say power as the amount of energy transferred or converted per unit time. Energy transformation is happening. So that amount of energy is called power. Power is equal to work done by time. We already said that work is the transfer of energy, and by that energy, some displacement is happening to an object. So likewise, power is equal to work done per unit time. So we can say unit as work. The unit of work is joule and D is second, so joule per second, or in SI unit watt. And power is also a scalar unity, so only magnitude, no direction. So my next topic is kinetic energy. Kinetic energy is a form of energy that possessed by an object due to its motion. If any object is moving, it it is having it is it is having a kinetic energy. That's it. If we are not able to write this much, we can simply say that kinetic energy is movement energy of an object. If an object want to move, that want energy, a movement energy, and that energy is called as kinetic energy. The equation for kinetic energy is half mv square, where m is the mass of the object and velocity is the speed or velocity of that object. That's it. So the next topic is work energy theorem. Work energy theorem is a principle of work and kinetic energy, and it is also the fundamental principle in physics. Also, the work energy theorem is the fundamental principle in physics, and this work energy theorem connects the concept of work and kinetic energy. Work done by all forces on an object is equal to the change in object's kinetic energy. Work done by all the forces on an object is equal to the change in the object's kinetic energy. If I am applying or I am doing some work on a bench, in a later example I told that I am moving a bench, so I did a work, so that work is equal to the change in kinetic energy, because due to my work the bench moves, so there is a kinetic energy, and that kinetic energy and the work applied by me is what is equal. That is, work net is equal to delta K. This is the net to work done, and this is the change in kinetic energy. And the equation is W work done is equal to change in kinetic energy, which is equal to half mv square F minus half mv square I, where F and I means F means final and I means initial. That means particle speed after the force applied, that is F, and the particle speed before force applied is I. And this and the use of this work energy theorem is, and it is useful for finding the work done by unknown masses. Useful for finding the work done by unknown masses. Even the amount of force or displacement is unknown. So this is the concept of work energy theorem.